All right, a very good evening to all of you. Welcome back to your channel of Learning Mathematics. This is going to be now the last exercise of vectors. So after that, vectors are done. So after that, again, we'll be going back to calculus again. But since this is the last topic, this is not a very big topic, okay? This is an application topic only of vectors. And actually, it's a very interesting topic also. So as we wait for maybe a couple of minutes till all of your friends join in, we can just, this is what we are going to be doing today in this video. So you can just have a look, get your book, pen, paper, everything ready. Let me see who have joined today's classes. Yes, a very good evening to all of you. Good to see all of you joining again regularly. All right, so most of the regular students are regular again. I can see some students who have joined again today for the first, not for the first time, but some students also have joined. So it's good to see all of you. And the more you join, the more the merrier, isn't it? So it's good to see all of you joining. So yeah, without wasting much time, I think most of your friends have already joined. So let us begin. All right, so fine then, once again, welcome back each and every one of you. This will be the last exercise of chapter 10, the scalar triple product. So today in this video, what we are going to be learning will be what is a scalar triple product, what is its geometrical interpretation, what are the properties, and yes, finally, of course, we will go to the solution of exercise 10.5. Exercise is not a very big exercise, it's a very small exercise. So we'll try to sum all this up in just one video today also. Don't worry, it's not going to take much, it's not going to take a very long time. As usual, maybe 1 hour earlier. But I know that you have the patience, so I guess everything is ready. So all right then, let's begin. So scalar triple product. What is a scalar triple product? As you can see, triple. So that means we are going for the product of now 3 vectors. Okay, we will be now going for the product of 3 vectors together. So let's see what is its definition mathematically. Okay, what is its definition mathematically and how do we represent it? The scalar triple product is represented generally like this. Within the box A, B, C, or sometimes also you can use commas also. Sometimes commas also might be given A, B, C, or sometimes nothing might be given, just like this A, B, C. There are different ways to denote. So do not be confused with the way it is being denoted, but more commonly use this one. Or yeah, comma is also used. So A, B, C. Now this scalar triple product actually is defined as in this form. That's A, B, C represents A cross B. A cross B dot C. This is what it represents. Alright, so the scalar triple product is defined as A cross B dot C. Got it? So as the name suggests, scalar. So that means we are expecting a scalar quantity here, resultant. Let's see what happens. Scalar triple product. Now the cross product of 2 vectors, of course, what will it give us? Definitely it's going to give us a vector quantity. C is also a vector quantity. It's of course a vector quantity. Now when you go with the dot product of 2 vector quantities, what have we learned in the first 2 exercises? We have seen that when you go with the dot product of 2 vectors, what do we end up getting? We end up getting a scalar. So that's basically what a scalar triple product is. Alright? Okay. I hope you're writing it down. Got it? All right, now let's see how do we actually solve it algebraically also. How do we solve it algebraically? How do we really find out the value of the scalar triple product? Now if we just assume three vectors, let's say vector A as A1i, A2j, A3k. I'll just write it here. Vector B as B1i, B2j, B3k, and vector C as C1i, C2j, C3k. Now I'm going to skip the process part. Alright, I'm just going to skip the process part. Let's get straight to the point, how to solve it algebraically in a very short time. Alright, how to solve it algebraically in a very short time. This is the shorter way. Okay, this is the shorter way. So it will be simply A cross B dot C, or in other words, the scalar triple product, that is A, B, C. You can use commas also, no problem, like this. Will be simply, do you remember determinants? I hope you remember determinants. It's going to be exactly that. That is, we are just going to write down the coefficients of the three vectors. That is, A1, A2, A3, B1, B2, B3, C1, C2, C3, and get its determinant. That's how simple it is. Okay, scalar triple product. Just write out the coefficients of the three vectors given to you, find out its determinant. As we all know, we are supposed to get a scalar quantity, so whatever value you get here will be the quantity, the value of the scalar triple product. So determinant, let me just not discuss that, because when we solve again we will practice, but determinants we have already done, and similar to vector cross product also. So it will be just the determinant of the coefficients of the three vectors. After that we'll be just solving it, but that's it. All right. Okay, with examples, of course, it will be much better for us to explain. So definitely we are going to be doing that also. So that's basically what a scalar triple product is, and that's basically how we will be solving it algebraically. Now, doing a very quick recap of what we have learned so far. That is, what was the dot product? Dot product was A, B, cos theta, or in other words, A, B cos theta, because magnitude doesn't matter. What was the cross product? A cross B, there's something to learn here. And remember last class I talked about this somewhere. So that is A, B sine theta into n cap. Now what does this n cap represent? N cap actually represents what? Or in other words, okay, let it be. I'll discuss about that later on. Or in other words, n cap actually represents what? This represents a unit vector that is perpendicular to each one of A and B, because it represents a vector, because this is cross product. So, and that vector will be perpendicular to each one of A and B. So for example, if it's xy, then resultant will be z-axis, either inwards or outwards. And I also told you that this value is also considered as the magnitude of A cross B, if you remember, and n cap. This value. If you remember last class, while doing one particular problem, I had told you that this is also same as the magnitude of A cross B. Now again, in that previous class again, we have also seen that what is this? A cross B, magnitude of A cross B represents what? You remember this? Volume of a parallelogram. So we will be slightly needing this concept. Alright, so this is something which you should know. Alright, A cross B is A, B sine theta into n cap, that unit perpendicular, which is also, this also is nothing but magnitude of A cross B. Of course, this value is going to be a scalar quantity only, it's just that because of n cap, we end up getting a vector quantity. So that is, A cross B is nothing but volume of parallelogram. Okay, alright then, so now let's see what is its geometrical interpretation. Like geometrically, what does it give us? Actually, the second point, geometrical interpretation. Geometrical interpretation. Now, what happens? Of course, you can first write down that is scalar triple product scalar triple product in briefly gives us the volume of the Parallelogram gives us the volume of the parallelepiped, okay, parallelepiped formed by adjacent sides by the three vectors, any three vectors, by the three vectors, if we consider vector A, vector B, and vector C. Don't worry, I'll tell you exactly what it means. So actually parallelepiped means something like a three-dimensional parallelogram. Okay, you know, it's a parallelepiped is nothing but 6 parallel planes. Parallelepiped is made by 6 parallel planes. So parallelepiped is something like you can call it as like a three-dimensional parallelogram. All right, that can be considered as a parallelepiped. So scalar triple product, actually we have seen vector cross product gives us how to find out how the volume of area of parallelogram, area of triangles, area of quadrilaterals. Now scalar triple product also will tell us or give us how to find out, you know, volume of parallelepiped. So this is its geometrical interpretation. Now I wish to quickly show you because these things are also very interesting. We will be learning maybe certain new things here. Now see, let me draw a parallelogram. As you all know, my drawing is not very good, but I'll try. You can also try. Let's draw a three-dimensional parallelogram. Let us give it a try. So this is a parallelepiped. So I hope you have liked my diagram. So if we say this is the origin, and let's say this is the vector A, this is vector B, let's say this is vector C. So far, I'll just, okay, anyway, I'll just write here C. Alright, so I hope my diagram is not very bad, of course. Okay. We're just trying to derive or prove or verify. Okay. So now, scalar triple product is what? A cross, look at this, okay, it's very interesting. A cross A, B dot C. So what is it? That is A cross B. Let me just write down that here. So that's like A, B sine theta into n cap dot C. That's what we get from the vector cross product. Now, as I've mentioned, this is nothing but A cross B. Magnitude of A cross B into n cap into dot C. So far, that's what we have. So, what does this represent? As I mentioned, this represents area of parallelogram. We're just trying to verify how the scalar triple product actually gives us a way to find out the volume of a parallelepiped. Okay, so area of parallelogram is done. Now, what will be this value? Let's try to have a look. What is n cap? N cap is actually what? The perpendicular vector that is perpendicular to each one of vector A and vector B. So if we assume this to be the vector A, vector B, then Fleming's left-hand rule, right-hand thumb rule, and all we have seen. If you go for A cross B, then the resultant will be outwards, or maybe outwards, basically anti-clockwise. So you'll have a resultant vector in this particular direction. So let me just draw that three-dimensional. I cannot draw. So let me just draw that perpendicular vector here. So let's say that this is the resultant vector n cap. Alright, because as we have learned, the n cap will be a vector that is going to be perpendicular to each one of A and B. So actually I have drawn it here, but it's something like this. Okay, either outwards or inside the board. So let's say that it makes an angle theta, because we have to find out now what what is the dot product of this unit vector with C vector? I hope you're getting it. Right. So, and let's name this as A, this point. So from here, I'm just going to rub this off once, just to clear certain things. From here, I'm going to drop a perpendicular, not perpendicular, parallel as well as perpendicular, of course, because this is perpendicular. So if I drop it down here, it's going to be perpendicular only. Let's say this is B. This is that A vector, okay? I'm just writing it again, and this is that B vector. So now what will happen is, since this is a parallel, these two are parallel lines that I've drawn, because it's a perpendicular, this is also perpendicular. So if I've drawn parallel lines, and in that case, if this angle is theta, then of course definitely this angle is also going to be what? Theta. I guess there's no doubt about that, isn't it? Got it, no? Because when I go for A cross B, the resultant vector will be a perpendicular vector to both A and B. So it's in this direction. So that one I've drawn it like this. So if I assume that the perpendicular vector makes an angle theta with respect to the vector C, because I have to find out the angle dot product. So actually dot product will be what? What was the dot product? A dot B cos theta. You remember that, isn't it? So that's going to be, I'll just write like this, area of parallelogram. This is n cap is 1. C cap is, of course, vector C is C into cos theta. Alright, so if I just write C, then C vector, its position vector is what? OA. Position vector is OA in terms of magnitude, because it's in terms of magnitude, isn't it? I think these things are clear, isn't it? Because C cap magnitude means C into cos theta. What is C? It's the vector C. So what will be the magnitude of the vector C? It's the length OA. Position vector only, isn't it? So magnitude of the position vector will be OA. Got it? So OA cos theta. So what is going to be OA cos theta? That is what I'm going to try to find out now. So now, I think this part is clear, because if this is theta, I've drawn a perpendicular, so this is also theta. So if I consider this triangle, alright, now I'm going to rub this part so that it will be slightly clean for you to observe. Okay, so I'm just going to rub this part. So now for cos theta, what will happen is cos theta. So if this is cos theta, adjacent side AB by OB. No. Yeah, AB by OA. So that's going to be AB by OA. Getting it? So OA into cos theta will be what? AB. So OA into cos theta will be nothing but, so again, I'm going to just write here, area of parallelogram into AB. Got that? So this one again, that is going to be area of parallelogram into, what is this? AB? AB is the, of course I hope it looks perpendicular. So AB is the perpendicular height, so that's going to be height. So if we just assume area, if we just assume 3 dimensions, so if we assume area of parallelogram to be, let's say, length into breadth, into height, another dimension, so that simply becomes volume of the Parallelopiped, volume of the parallelepiped. So that's the verification or the proof that the scalar triple product gives us the volume of a parallelepiped. So these are some things which we should actually not skip. Okay, finally, all right. So that's a big part done. So the rest are simple parts. Properties, quickly note down very important properties. Properties of scalar triple product. Properties of scalar triple product. Number 1, or let's say number A. I hope you're writing it down. Chalo. A very good evening to all of you. Many of you are joining the classes. It's very good to see that. So a very good evening to all of you. All right. Properties of scalar triple product. The first property, very important property, that is cyclic permutation. Cyclic permutation of Scalar, in short only I'll write, okay, scalar triple product. In short only I'm just writing. Cyclic permutation of a scalar triple product. Cyclic permutation of a scalar triple product is same. Cyclic permutation of a scalar triple product is same. Now, what do we mean by this? That is, if you mention that orthonormal triad, orthogonal triad, cyclic permutation, that simply means, you see, for a scalar triple product, A, B, C, you know that scalar triple product, what is it? In the beginning, I gave you to solve it algebraically. It's the value of the determinant only, of the coefficients of vector A, B, and C. If we maintain its cyclic permutation, then the scalar value of the scalar triple product remains the same. That means ABC will be same as cyclic, okay, not randomly. So ABC will be same as BCA. That also will be same as, so ABC, BCA, CAB. So as you can see, if we just maintain the cyclic permutation, that is A, B, C. So ABC is equal, no, ABC is equal to BCA is equal to CAB. So if you maintain that cyclic permutation, what happens? The value of the scalar triple product doesn't change, it remains the same. Alright, a very important property there. But if it's not done cyclically, if it is done randomly, then of course this value will change. That is the second property. You can write down change of cyclic order. Write down change of cyclic order changes the sign of scalar triple product. Change of cyclic order changes the scale of scalar triple product. That is, in just one example, ABC will be equal to, now instead of BCA, if I just write, maybe if I just change it randomly, that's like if I just write it like CBA, you know that this is not cyclic, isn't it? Right, because if it has to be cyclic, then it has to be BCA, CAB, but I just changed it as CBA. Then in that case, just like determinants, if we exchange the rows and columns, just one rows and one column, we know that the sign changes, isn't it? So most of the properties are from determinants only here, okay? So there will be a sign change in the value of the scalar triple product. Alright, yeah, very good evening to each and every one of you. Some have joined for the first time, of course, it's very welcome. Very good to see all of you joining here. Alright, so these are the two properties. Of course, there are more. I hope you have written it down. Okay, I'll go to the next property, that is number C. You can write down in scalar, in short only I'm writing, okay, in scalar triple product, the dot or cross, that means the dot product or cross product, can be interchanged, okay, can be interchanged in cyclic order, in scalar triple product, the dot or cross can be interchanged in cyclic order. Just an example, A cross B dot C can be just written as A dot B cross C, because do remember that what is A cross B dot, it's a determinant only, A1, A2, B1, B2, C1, C2, C3. This will also be same if you go for it, no, because it's also the scalar triple product only. So this will also be A1, A2, A3, B1, B2, B3, C1, C2, C3. Remember, you have to maintain the cyclic order. If you don't maintain the cyclic order, what happens? There will be a sign change. These are simple properties, and those who have done determinants well, you will understand. If not, please go to the videos, because we have solved the complete exercises also. Another very common property that is from that also again comes from properties of determinants also again, that is the scalar triple product is 0. You remember when was the value of a determinant 0? The value of a determinant was 0 if any two rows or any two columns, if the corresponding elements of any two rows or any two columns are equal or proportional, same thing. Alright, because this property follows from there, that is the scalar triple product is 0 if any two vectors are equal. That means, for example, A, C. Well, this kind of values will be what? 0. Because we can clearly see that if we just expand, that is A cross A dot C. So we have seen that the cross product of like vectors is also what? 0. So there's nothing much to prove there. Just examples only. Okay? We don't have many problems to really teach us all this. So as I've always mentioned, you need to consult many other books, reference books also. Then only you can perfect your art. Okay. Number 5. The scalar triple product is again 0. The scalar triple product is again 0 if any two vectors are parallel or collinear. That's again because of the cross product concept. If any two vectors are parallel or collinear. Got it? Alright. Okay. The last property and the most important property with respect to the exercise that we are going to be solving. Okay? Okay. You can write down number 6. Not 6. A, B, C, D, E, F. This would be F. The necessary and sufficient. You can write down the necessary and sufficient condition for 3 non-zero. For for 3 non-zero, non-collinear vectors. For 3 non-zero and non-collinear vectors, let's say A, B, C. To be coplanar is that the scalar triple product of these 3 vectors would be 0. Coplanar means they are all lying on the same plane, like on the board, all the writings are lying on the board. So these are like coplanar, like for example this point, this point, this point. So they're all lying on the board, so these are called coplanar points. So the necessary and sufficient condition for the 3 non-collinear and non-zero vectors to be coplanar is the scalar triple product should be 0. That means if the 3 vectors given to us are coplanar, then even the volume of the parallelepiped will be 0, because volume, the parallelepiped, the vectors are spread out. So if they are all lying on the same plane, then patash, they will all fall flat on one plane. So in that case, we cannot have a parallelogram or a 3-dimensional parallelepiped, isn't it? Not possible, right? So in that case, the volume of the parallelepiped is also 0. Got it? Alright, so that sums up the properties. So the last point for today, the last job for today, that is what? Solving the exercise, which is exercise number 10.5. In some NCERT textbooks, this 10.5 is not there. So let's see. So alright then, time for already a half hour mark. So we know what to do, isn't it? What do we do whenever we reach the half hour mark? What do we do? What do we do whenever we reach the half hour mark? Yes, those who are regular, you can tell us. What do we do when we reach the half hour mark of every class? What do we do? Yes, water, water, water. So let us all refresh ourselves with a sip of water. In the meantime, those who have the question, yes, glass of water, great. So in the meantime, you can prepare for your exercise also. Very few questions, so we'll wind it up, I guess, a lot quicker compared to others. All right, not juice, water will be much better. All right. Okay. Yeah, a bottle of water. A glass of water. A glass of water. For once I thought a bottle of vodka. I was surprised. Okay, so the question is find the scalar triple product, where the vectors given to us are I, 2j plus 3k, vector b, 2i minus 3j plus k, and vector c, 3i plus j minus 2k. So a simple exercise for us. So as we know, the scalar triple product is nothing but the value of the determinant formed by the coefficients or the scalar components. So for vector A it's 1, minus 2, 3. 1, minus 2, 3. For B it's 2, minus 3, 1. And for C it is 3, 1, minus 2. Everybody knows how to calculate the value of a determinant. So chalo. So that's like 1 into 3 2s are 6 minus 1. Minus of minus 2 into this one. 2 2s are minus 4 minus 3 plus 3 into 2 1s are 2 minus 9. So yeah, the results will be out. I hope all of you have got the notification. The results will be out by July 20. The board exams class 10 and 12. So I hope you have some family members or friends waiting, anticipating for the results. You can tell them results to be out by 20 July. So hardly, I guess, 5 to 6 days left. So tell them to pray well. So 33 plus 5, 38. 38 minus 14, 24. So as we can see that the result is a scalar. So that's why it's called scalar triple product. The result that we get is a scalar. Yeah, I forgot something. Today also we are almost approaching the half century mark of likes. Actually our likes are increasing a lot. So I'm like, I think now I should go for 100 likes now next, because 50 likes is like becoming now very easy for us to get. With your support, of course. Without your support, all of us, I know especially, would not have been possible. But now my hopes and anticipations are becoming now bigger. I guess I'm becoming more greedy now. You made me greedy. So you can see today also Aram se we have reached almost 50 likes. Alright, so that's it. Let's move on to the second question. Alright, we have reached the half century mark. Okay, thank you everyone. We have got the half century marks. But as I said, do you remember again? I would be more happy if all of you can get this half century, at least this half century in your exams. Then I would be very, very happy. I hope you're not going to let me down. All the hard work that we have put in together since last year, studying together, I am sure that you're not going to be letting me down. So please don't let me down, okay, my dear students? I'm counting on you. Even though we have not met, it seems like we are a family now. Of course, we are a family. Okay, the second question is, show that the vectors are coplanar. Show that these three given vectors are coplanar. So how do we know that? We have no idea about that. We'll have to find out the scalar triple product. If it turns out to be 0, then chalo. So we'll have to get the scalar triple product and check. If it is 0, then yes, we can verify. So let's begin. 1 into 3 5s are 15, minus 4 3s are 12, minus 2. I'm going to write it directly now. Minus 2 plus 2. So plus 2, 5 2s are minus 10, minus 1 4s are 4, minus 4 plus 4. Plus 3 into 2 3s are 6, minus 3. So that's like 3 plus 2 into minus 6 plus 3 into 3. So that's like 3 minus 12 plus 9. So definitely 9 plus 3 is 0. So this is also 0. Hence, conclusion, they are coplanar. Hence, they are coplanar. Not a difficult job. Alright, next question number 3. Question number 3. If the vectors, so the vectors are not named, so we'll just name the vectors. Let A equal to this vector, vector B equal to 3i plus j plus 2k, and the vector C as I plus lambda, lambda is missing here, minus 3k. So the question is, find lambda. Find lambda if the three given vectors are, I'm not writing down the full question, coplanar. That means if the three given vectors are coplanar, find the value of lambda. So since vector A, B, C, since the three vectors are coplanar, their scalar triple product will be 0. So how do we find out the scalar triple product? That is coefficients 1 minus 1 1, 3 1 2, 1 lambda minus 3. It should be 0. Let's calculate this. So that's like 1 into minus 3 minus 2 lambda minus plus 1 into 3 3s are 9 minus 2 plus 1 into 3 lambda minus 1. 3 lambda minus 1 equal to 0. So that's like minus 3 minus 2 lambda minus 11 plus 3 lambda minus 1 is equal to 0. So that would be 3 plus 3 minus 2, that's 1 lambda. 11, 12, 13, 14, 15 minus 15 is equal to 0. So yeah, lambda will be 15. So the value of lambda should be 15, so that the given vectors are coplanar. Okay? Question number 4. You can write it down as I prepare the question 4 for us. I mean, I'm not going to write down the question, I'm just going to write down what are the vectors given to us. So the vectors A, B, and C are given. C1i, C2j, C3k. So, okay, then the first question says if C1 is 1 and C2 is 2, find C3 which makes the three vectors A, B, C coplanar. Which makes the three vectors coplanar. Simple questions, we know what to do. So A, B, C are coplanar or will be coplanar if their scalar triple product is 0. So what is the scalar triple product? 1, 1, 1. B, if we have only I cap, so that's only 1, 0, 0. And C, we have of course C1, C2, C3, if this is 0. So now rewriting that again, 1, 1, 1, 1, 0, 0. C1 they're given us 1, C2 they're given us 2, and C3 we are supposed to find out for which the three given vectors would be coplanar. Now if we just calculate 1 into 0 into 0, 0 minus 0, let me just write it down. This will be C3 minus 0 plus 1 into 2 ones are 2 minus 0 equal to 0. So that's like 0, this is like minus C3, this is like plus 2 equal to 0. So minus C3 equal to minus 2. I'll just write here less space. So in that case, C3 should be 2. So the value of C3 should be 2, so that our given vectors A, B, and C are, of course, coplanar. Done? Second question says if C2 is minus 1, C3 is 1. If C2 is minus 1 and C3 is plus 1. Show that no value of C C1. Show that no value of C1 can make C1, C2, C3 coplanar. Alright, so C1 is that clever person who wants all his friends or her friends to fail. You know, we come across some people like they will not study, they don't want others also to study. So you have to be careful with that, all of you. This is for your own good, all of us, we need to be careful about that. We need to vector A, B, C are coplannars, so that no value of C1 can make A, B, and A, B, and C coplanar. I was thinking of that particular person. Okay, so that C1, so that none of the vectors would be coplanars. So as I was saying, no offense, but as I was saying, we come across different kinds of people. There are some kinds of people who they will not succeed, or they are lazy, but they don't want others also to be doing. Or others also they don't want others also to be succeeding through hard work, and also we really need to be careful with that. Okay, we really need to be careful in the friend circle that we choose and all, because some are like, I don't want to study, but okay, I'm not going to let him also study. So that's not good. I'm sure that you are not doing that, but you need to be careful of all this. That's the way the world is. We can't blame anyone. It's not anybody's fault. That's the way the world is. But as I used to say, you should not be losing your focus. You know what you want in life, isn't it? You know what you want in life. Nobody wants to be hungry. Nobody wants to be poor. Everybody wants to be successful. Everybody wants to achieve things. But for that, there is a price to pay. That's hard work, sacrifice. Nothing comes easy, okay, in life. So we need to put in that effort, we need to put in that sacrifice, we need to make that sacrifice, we need to be determined, we need to be focused on our goal. That's when we go and achieve. And trust me, I'm going to tell you something, that is, trust me, nobody is born perfect, and nobody is perfect also. Alright, it's an art. As I say, mathematics is an art. Nobody is born good in mathematics. Absolutely. Nobody is born good in mathematics. No. It's just about practice. Is how much do you want to learn? How badly do you want to succeed in life? It's all about that only. How badly do you really want to achieve things in life? It's about that. And definitely, if you remain true to your goals, one day I'm sure you are going to succeed in life. So, but for that, you need to put in some sacrifice actually at this moment, because at this moment you are standing on the cliff. Your life is at stake. Your educational career is at stake. So don't be just easily swayed away by the worldly pleasures which will not last. So now put in some sacrifice, work hard, be determined. I'm sure one day when you look back, you will be happy, and you will say to yourself that those sacrifices that I've put in was not a waste. It was worth it. So yes, please stay out of trouble, stay safe, work hard, be determined. You always have to encourage yourself, okay? You always have to motivate yourself. So continue to do that. I'm sure you will be very successful one day. Each and every one of you who are looking, who are with me here today now, I'm sure that you are going to be successful in life, because your actions show that you are interested in learning. So you keep this attitude, definitely you are going to grow. Trust me on that. Our attitude matters a lot, okay? So anyway, forget about that. So the three vectors are given, C2 is given, C3 is given. So show that no value of C1. So C1 is that bad guy, that bad guy who doesn't want ABC to be coplanar. So show that there are no values of C1 that can make actually A, B, C and coplanar. We don't know, let's see. There are many ways to do it. I'm just going to do a very simple way only. That is, ABC will be like coplanar if we are just assuming that there is a value of C1. Okay, we are just assuming that there is a value of C1 which will make ABC coplanar. If that is the case, what is going to happen? Writing down the coefficients once again. C2 minus 1, this is plus 1 equal to 0. Now if you go for the determinant, that's 1 into 1, 0, 0, 0, 0. Minus 1 into 1, 1, 0, 1 minus C1 into 0, 0. Plus 1 into minus 1 minus 0. There is no C1. C1 already disappeared. As you can see, C1 has already run away. You can clearly see, very clever. Run away already. Started the problem, bhag gaya. So it's like, anyway, let's just complete 0 into minus 1, this is plus 1 minus 1 equal to 0. So what do we end up getting here? Something that is very unique, funny. That is C1 to not there, and on top of that we get minus 2 equal to 0. Which is absolutely not true. So hence there is no value of C1. That's what, minus 2 equal to 0, so that is not possible. And on top of that, C1 to already bhag gaya to. After starting the fire, already run away. So C1 to already run away, C1 is not there. On top of that, we are getting a very funny equation, that is minus 2 equal to 0. There are other ways to solve this also, but it's just a simple way to solve. So minus 2 equal to 0, which is definitely not true. How can minus 2 be equal to 0? So that just verifies everything. That just explains everything, that definitely there is no value of C1, which will make, conclusion you can just write down like, oh, hence there is no value of C1, which will make A, B and C friends forever. No, not friends forever, sorry, Coplanner. Alright, number 5. Show that the 4 points with position vectors, this are Coplanner. Be careful with this. There are 4 points. You have to show that the 4 points with position vectors, not vectors, position vectors are Coplanner. Let the position vector of, let's just say A, OA vector, OB vector, OC vector, OD vector. Let's first convert that into respective vectors. I'm going to give you another formula here. When you have, these 4 vectors, how do we prove that they are Coplanner? 4 vectors. But they are all position vectors only, so they are basically not like vector terms, So, of course, vectors. 4i plus 8j plus 12k. 2, 4, 6. 2i, 4j, 6. 3, 5, 4. 3i, 5j, 4k. 3, 5, 4. 5i, 8j, 5k. Good evening, life goes on. Alright, good evening all of you. Good evening. So these are the position vectors of the given points A, B, C and D. Write it down. I'm going to give you one, not a shortcut, but another formula to really find out the volume. What is the question? Show that the 4 points are Coplanner. So if 4 position vectors or 4 points are given, how do we prove that they are Coplanner? That is like this. We can write down 4 points are Coplanner if the scalar triple product of vector AB, AC, AD is 0. So if the scalar triple product of AB is AB, AC, AD is 0, then we can say that the given 4 points are Coplanner. So that means we have a lot of work to do. That is, we have to find out AB, we have to find out AC, we have to find out AD. I hope you have written it down because I have to rub it off, because I have to find out the vectors for you, AB, AC and AD. Written? I'm rubbing it off. Okay? Written, no? Okay. So let's find out the vectors quickly. So let's find out the vector AB first. So AB will be, as we know, I hope you remember, it's going to be OB minus OA, isn't it? Second vector minus first vector. So let's subtract directly. OB minus OA. OB minus OA. 2 minus 4 minus 2I. 4 minus 8 minus 4J. 6 minus 12 minus 6K. Correct me if I go wrong anywhere. AC vector OC minus OA. So C minus A. 3 minus 4 minus 1. 5 minus 8 minus 3. 4 minus 12 minus 8. And AD vector OD vector minus OA vector, that is OD minus A. 5 minus 4. Okay, this time positive. 5 minus 4, 1. 8 minus 8, 0. 5 minus 12, 7. Okay, I hope I've got it correctly. You can just kindly check any corrections. Let me know. Minus 2, minus 4, minus 6, minus 2, minus 4, minus 6. Because somewhere we go wrong, the whole solution is gone. Minus 1, minus 3, minus 8. 1, same, minus 7. 5, 8, 5. 4, 8, 12. 2, 4, 6. 3, 5, 4. So far so good. So let's find out the written. Okay. We have to prove that they are coplanar, so let's find out the scalar triple product, that is AB, AC, AB. Determinant. Minus 2, minus 4, minus 6. Minus 1, minus 3, minus 8, 1, 0, minus 7. So that's minus 2 into 21 minus, okay, that's 0. So minus plus 4. 7 minus 8 ones are 8 minus 8. Minus 6. 1 0 0 0 minus 3 ones are 3 minus plus. So I'm just going to continue here. Is equal to minus 2 ones are 2, 2 2s are 4, 42. Plus 4 into 7 plus 8, 15. Minus 6 3s are 18. So minus 42 plus 60 minus 18. So 4, 9, 10. Minus 60 plus 60. Bingo. So what do we get? Bingo. Mad angles. So what do we get? The scalar triple product to be 0. So conclusion, I guess all of you can write, since AB vector AC AD, since their scalar triple product is 0, the 4 points are coplanar. So given 4 points are coplanar. Okay. Alright, chalo, let's just 2 more questions left. Let's do it quickly. So it's a similar question with the next one, so I'll just tell you how to do it. Question number 6, no, it's slightly different, so anyway I'll have to do it. Chalo, no problem. Question number 6, the points are given here, position vectors are not given, but 4 points, we know what to do, isn't it? It's very simple. What do we do? Position vector of A, same again. OA vector, OB vector, OC vector, OD vector. So quickly follow me. 3, 2, 1. 4x 5. 4, 2 minus 2. 6, 5. 6, 5 minus k. 6, 5 minus k. That's alright? So the question is now here, find x such that the 4 points are collinear. Find x such that the 4 points are collinear. So you have to find the value of x given that the points are actually already collinear. No problem, but for that what do we need? We need AB, AC and AD. So let's find out AB vector, AC vector, AD vector. So this one I'm going to do it directly. So AB, OB minus OA. Na? So 4 minus 3, 1, okay, 1I. This will be x minus 2j, 5 minus 1, 4k. Fine. AC, C minus A, 4 minus 3 again, 1I, 2 minus 2, that's already 0. Minus 2 minus 1 minus 3k. Next 6 minus 3, 3I, 5 minus 2, 3j, minus k, minus 2k. Try to be patient when you do mathematics. I hope I got it correctly. 4 minus 3, 1, x minus 2, 5, 4. 4 minus 3, 1, 2 minus 2, 0, minus 2 minus 3, 0, 3, 3, minus 2. The 4 points will be coplanar if their scalar triple product is 0. Let me just try to fit in here. 1, x minus 2, 4. 1, 0, minus 3. Three, 3, minus 2. 3 3s are 9 minus plus minus x minus 2 into minus 2 minus 3 3s are minus 9 plus 9 plus 4. 3 1s are 3 minus 0. So 1 into 9, 9 minus x minus 2, 7 plus 4 3s are 12. So 9 plus 12, 12, 21. 21 minus 7x minus minus plus 14 is equal to 0. So let me complete here. 535 equal to 7x. So x will be equal to 5. Simple question again. Simple exercise, this one, not a difficult exercise. Good night, good night, good night. Okay. Alright, so if that is done, the last and the final question, which is a very good question again. Conceptual question. That's about knowing the properties of, cross product, dot product, scalar triple product. So it's a very interesting question. There were many questions like those in the previous textbooks and all, other textbooks and all, but anyway. Question is, show that the vectors. Last question, be with me, I hope all of you are there. Show that the vectors A, B, C are coplanar if you can see it is very cyclic. Show that the given vectors A, B, C are coplanar if the vectors A plus B, B plus C, C plus A are coplanar. How do we prove? Just so many questions we have been doing about now coplanarity. So this is the last question. So how do we prove that they are coplanar? Their scalar triple product should be 0. Let me just have a glass of water. Last question. To prove that the vectors A, B, C are coplanar, we should prove that their scalar triple product, something like this. This is scalar triple product. This should be what? 0. From where do we begin? What is the condition given? The condition given is these three are coplanar. Given these three vectors are coplanar, because if they are coplanar, then of course their dot scalar triple product will be what? 0. So that means the cross product of these two vectors, I mean not the cross product, let's say scalar triple product. Scalar triple product means this one, no? Just that the vectors are looking quite different, but should be 0. Let's simplify this. Simplification only, cross product, multiply. So what will it be? A cross B multiplication. A cross B plus A cross C. Plus this one, B cross B plus B cross C. Cross C. Dot product with C plus A. That we will deal in the last. Now what is left here? That is A cross B plus A cross C. B cross B, we have already seen cross product of like vectors 0. So I'm not going to write if you wish, you can write down B cross B is 0. If you think you might just be confused, how did it turn out to be 0? Remember, this is dot product. Now let's again go for the dot product. So A cross B dot C plus A cross C dot C plus 1 by 1. Nah? Simple expansion, B cross C dot C. Continue again, plus A cross B dot A plus multiplication, A cross C dot A plus B cross C dot A equal to 0. Are you done with this? Alright, let's try to arrange, because what is this? This is a scalar triple product. So this can be arranged as A, B, C, ain't it? No problem with that. Scalar triple product, no? This is A, C, C plus this is B, C, C plus A, B, A plus A, C, A plus B, C, A equal to 0. Just arranging back to the standard form of scalar triple product. Almost done. Write it down. Almost done. Just 2 steps. Okay? Written? Which is the easiest chapter in our syllabus? Honestly speaking, none of the chapters are easiest. And again, honestly speaking, all the chapters are easiest. See, mathematics, basically speaking, mathematics, there is no easiest and no difficult chapter, okay? Because once you know the concepts, you know the basics properly, every chapter is easy. Differentiation, integration also, these are also very easy, okay? Like, it would be unjust to for me to just say that one particular topic is easy, difficult. Maybe in terms of scoring process, yeah, in terms of the syllabus, in terms of the content, there will be some topics which are small, like these chapters, which are like small in content. So this may be easier for us to study or to prepare for the examination point of view. But I simply cannot say that vectors is easy, or I again cannot say that calculus is like difficult or easy. So these are relative terms. So it depends. It depends on how well you know your concepts and how strong you are in your concepts and practice. So honestly speaking, there is no easy and there is no difficult chapter. Actually, it will depend on you only. Yeah, but in terms of maybe the syllabus, the content, yeah, based on that maybe we can judge, okay, this chapter is small so I can do that, this chapter is huge, vast. So yeah, maybe in terms of that, some chapters may be considered as too vast, simple, but I don't have that judgment like easy, difficult. No, everything is difficult and every chapter is easy. Practice, practice, practice. That's the general rule. You will find everything easy. Bus. All right. ABC plus 0. You know why this is 0? Remember? If you remember, which property was that? Property number 4 or 5. If two vectors are equal, then it is 0. You remember that? 0. This also 0. AA, that also 0. This also 0. This is BCA. Equal to 0. So ABC plus, now BCA, this is in the cyclic order again. If you remember, if the cyclic order of scalar triple product is maintained, then the value is same. So ABC, BCA, CAB. So BCA can also be written as AB, C. No problem, isn't it? Equal to 0. Because they are same. Because it is maintaining the cyclic order, no? Remember, right? I give you the property. You can check that property. So as long as the cyclic order is maintained, the value of the scalar triple product is 0. So this is simply 2 times of ABC equal to 0. So 2 goes on the other side. That proves that the scalar triple product is 0. That's what we were supposed to prove. Hence proof, which proves that the three vectors A, B, C are Coplanner. Alright, my dear beloved students, that's it. That sums up another chapter for us. With your due support, I have been able to finish what I really wanted to do. So, as I always have said, without your participation, I could not have done all this. But another chapter done. Another chapter finished again. So, next again, to move on to again calculus portion. So thank you one and all for joining, and yes, if you still haven't subscribed, please do subscribe, and don't forget to like the video if you have liked it before going. Okay, all right then, and please do share with your friends also who might I want you to share this channel also, so that your friends will also learn from it. All right, if you find it worth sharing. Okay. Alright then, I'll see you in the next video then. Bye bye, take care, sleep well. Good night and stay safe. Bye bye.